Welcome to the Virtually Speaking podcast. My name is Pete Koehler, and joining me as usual is my good friend, Mr. John Nicholson. John, VMware Explorer is upon us, my friend.
Yeah, I'm preparing right now, and by the time that you're hearing this, the show's probably already started. But I'm doing two important things. I'm making sure my hat gets packed,
yes,
and I'm taking more snapshots in my lab. So for those of you who want to see what evil snapshot atrocity war crime is being built, come check out the vSAN workshop with Pete and I.
Yeah, for sure. A little backstory for those that are not following along. But yeah, John has been creating a nice, creative, very hilarious list of snapshots that he's taking. And he's going to go over that in his session on Monday, where they're going to actually delete those. And we'll see how long it takes to delete it.
Sunday. I need a movie announcer guy to pre-announce the snapshot discussion. So it'll be fun.
Nice. Well, yeah, today officially when you're hearing this is Tuesday, and so Tuesday is release day for vSAN. vSAN 8 Update 2 was just announced, and joining us again to talk about all the details is our good friend, Mr. Pete Koehler. Pete, welcome back.
Yeah, thanks for having me, guys. And I know that we are doing this recording in advance, but I can guarantee you that my voice sounds better now than it will later on in the week at Explore, as it is for the case for all of us.
Absolutely. So, Pete, we were talking before the show, and I'm just curious. There's different types of people, different types of trips to Vegas. Some people go for bachelor parties or whatever. Some people go strictly for the gambling. Some people just go and lay poolside. What does your typical week in Las Vegas look like?
Usually it's just me trying to follow the food. So, whomever is paying for the dinner, I'll be there. I try to not get lost. And if I am lost, make it look like I'm not. So,
Are you the guy that stays inside the hotel the entire week, or do you venture out?
Well, it all depends on what the team does. And that can be that can really vary, because it's you would think that would be sort of like a fair vote on what we should do.
Yeah.
But that doesn't always seem to work out that way. We end up going, maybe to a place that maybe has a sordid past that you go, okay, well, all right, we're going here again. But, I think it's all in good fun, and looking forward to it for sure.
Oh, absolutely. Yeah, everyone loves going to VMware Explorer, previously known as VMworld, and we've had many good memories in various locations. Some seedier than others, but definitely always a good time at VMware Explorer. John, what about you? What are you planning for this week?
So I think the key thing is week. If you're doing a week in Vegas, it's a work week. I'm not going to see the sun. I'm going to be being shuffled from room to room to VBC. To hopefully having some hallway chats with you guys. But if I'm there for fun, I don't go for a week. I go there for 24 hours. I get on that plane, I'm off the plane by 9 a.m. I'm at the pool by 10. After a light lunch, it's spa time. Get that massage, get a facial, get a shave, go hit the little spa rooms. Then it's maybe a magic show or something. Then it's try not to hit dinner till maybe 9. Get out of dinner at midnight. Then go hit some tables, get 3 hours of sleep, and get out. Vegas, you either do it for work and you're there for days or week. If you do it for fun, I'm a big believer in the 24-hour rule.
That's pretty exciting, man. I've never tried it like that. I'm gonna have to try that one day. So good stuff. But yeah, we're here. It's Explore Week. There's a lot of great sessions going on. The general session was just today. So many great announcements. One of which for vSAN specifically. And Pete, I want to unpack a lot of the features, but I think the big one that I heard about is vSAN Max. So tell us what that's about. What exactly is vSAN Max?
Yeah, most certainly. So vSAN Max is our brand new fully disaggregated storage solution for vSphere clusters, meaning that you can build out a fully disaggregated storage cluster for the purpose of providing storage resources for your vSphere clusters. And the neat part about that is that you're going to be able to take advantage of all of the features of vSAN, but still have the separation or the decoupling of compute resources with storage resources. vSAN Max is built entirely on vSAN ESA, or the Express Storage Architecture. So you're going to get all of the goodness there that we've been showcasing over the last year or so. And this is really exciting news for many of our customers who have actually been asking about some sort of a solution like this. And it's really impressive in so many different ways. And we're excited to show a little bit more about it here throughout the week.
Yeah, and I'll play devil's advocate a little bit. So why wouldn't I just use a vSAN cluster using ESA? Why would I go with the vSAN Max route?
Yeah, the main driver that we had in working on this solution was the fact that we had a lot of our customers who were realizing that for certain workloads, and as they were assembling these workloads in their environment, that the needs of their storage resources were not growing at the same rate as their compute resources. So they wanted the ability to sort of scale those independently a little bit more. And that's something that they were used to in a traditional three-tier arrangement, but they had moved off of a three-tier arrangement because some of the inherent challenges that they would have naturally with scaling in those environments and manageability, and some of the costs associated with it. Now they're able to take HCI because they can scale incrementally. They can manage this thing that's just all embedded right inside the hypervisor and managed in vCenter Server. But they can meet all of those other capabilities that a traditional three-tier storage arrangement worked really well on. So they have the benefits of both. And we really see customers all running, of the benefits of vSAN HCI-based clusters, which are fully aggregated, as well as vSAN Max storage-only clusters side by side, where those vSAN Max storage-only clusters would be powering their vSphere clusters that are, offering up a variety of different workloads for their internal needs.
So with the word max, I assume that it's kind of a loaded term. I expect kind of two things. One, there's got to be an FDA warning. Don't combine this with, alcohol or driving or operating heavy equipment. And then two, the other thing also I'm kind of expecting here with the max is scale. So what is the scale that I'm going to be looking at this solution necessarily versus a traditional HCI? What are the I don't want to say buying patterns, but what are the architecturally, what are the situations I'm going to get myself in where I'm going to go reach for max rather than, the regular size vSAN, I guess.
Sure. Yeah. The naming is always an interesting thing. Let's get that out of the way. It's always a bit of a mystery when we work through this process, I think, for many of us. And, when you choose a superlative like that, max, well, what does that really mean? Is it, a better than vSAN more? We're not quite sure, So vSAN Max, though, is really focused on offering up petabyte scale storage. And that's really the key behind all of this. So when you're using vSAN Ready nodes certified for vSAN Max, those will have storage densities that go up to 360 terabytes per host. So when you think about that, and the possibilities there, where you have a 24 host vSAN Max cluster, that's over 8.5 petabytes, if my math serves me correctly, which it may not. So I could be wrong on that.
8.6. I checked 8.6. It.
Okay. So that offers tremendous flexibility for a lot of our customers, and they'll be able to apply this for a lot of scenarios that they have in their data center. So imagine you have cases where you have applications that have licensing structures that, sort of require you to kind of keep that footprint relatively small. You don't want to pay any additional licensing costs for this really expensive database application, whatever the thing may be. And so then you can kind of tailor a vSphere cluster that is smaller so that you can maintain some of those costs. So that's oftentimes what you see sort of in those situations where you just have a vSphere cluster and you're using external storage. That would be very applicable here. The other thing would be lengthening the life of some of your other servers in the environment, whether they're blades that were never well intended for a fully aggregated HCI cluster like vSAN. That would be another case as well. So if you have a sprawl of various servers really you can connect up to a vSAN Max cluster as long as you have 10 gig networking. Those servers in those vSphere clusters, they don't have to be adherent to any vSAN HCL. They just need to be on the vSphere HCL.
Well, and that's nice because if I'm 3 years or 4 years into running some blades for 7 years or 8 years into the ground completely, I don't, even if I could run vSAN on it, even if there were the drive slots, I don't want to recapitalize an asset that's going to fall off my books in 48 months. And so being able to procure that storage separately, especially if maybe I have an existing storage array that really is 8 years old and it's got to go, people aren't always in the position to buy compute and storage, even if they did have a fixed resource. So that seems like that, from a toolkit wise, opens up some possibilities.
Nice.
Yeah, indeed. And one of the things that's really interesting as well is that, and we've all been through the procurement process for when we were on that side of the business. One of the things that is really challenging is trying to plan in advance how much actual capacity you need in the first place. And so, should I get that storage solution that offers me X amount or X amount times 1.5? That's the hardest part. And the level of incremental scalability that you have with vSAN Max is really nice here. I mean, we're really allowing our customers to capitalize on the fact that you have this fully distributed storage system, and that brings so many great capabilities, and it certainly has for a fully aggregated environment like a vSAN HCI cluster. But now we're offering that as general centralized storage for your vSphere clusters. And we're really excited to see how this is going to really help many of our large customers and small customers as well.
Sure. And I'm imagining, because it is vSAN, and like you said, it is built on the express storage architecture, I'm assuming the deployment is pretty straightforward. It's essentially like I would do a regular vSAN cluster. How do I determine at what point in the deployment process do I say, hey, let's make this one a vSAN Max cluster?
Yeah, I think, and John can correct me if I'm wrong, but I think it's like 3 clicks. I mean, it is, you highlight the cluster, you configure the vSAN services, and it's going to make the option available of, is this a vSAN HCI cluster, which is a traditional vSAN cluster, or is it going to be a vSAN Max cluster? And then that's really it. And
yeah, I've been working on the demos for this, and it's one of those things where the demo is both short and almost disappointing and lacking of complexity and things. It's like, oh, okay, it's a Max cluster, cool.
Yeah.
And then the mounting the cluster is you're using the existing data store sharing wizard, which you have all the health checks that'll fire off to make sure connectivity's there, all that stuff. So you're going to get like 10 green checkboxes, or you're going to get a lot of red X's and, go home and try again. But it's operationally very simple.
Sometimes boring is nice, though. I mean, I would like to see a video on how to turn a light switch on. To be very simple. It should be like, click and it's on. That's it. I don't need to.
It's okay, Pete. You can fall asleep to my demo video of how to set up vSAN Max.
Next finished.
Yeah, and that sets almost a bit of a segue for some of the things that we've been doing in other parts of vSAN, and especially within the express storage architecture, which simply makes things easier. That's been the underlying goal in a lot of these things, and we had some technical implementation, so to speak, with the original storage architecture that was a little bit of a management burden for many of our customers. Well, when you remove those things, then it becomes easier. And so we're applying some of those simpler workflows to vSAN Max just as they would exist in the vSAN ESA. So one of those examples about making things easier is our new auto policy management feature. That was something that we introduced in vSAN 8 Update 1. And that's just all about creating a cluster-specific default storage policy for a vSAN cluster based off of the makeup of the cluster itself. Is it a stretch cluster? Is it a standard cluster? How many hosts are in there? And are you using the capacity management mechanism known as host rebuild reserve? And then builds a custom default storage policy for that environment. Well, now that we have that in place and it's fully applicable to a vSAN Max cluster, then you can sort of do this approach where it's a set it and forget it. You have the storage policy that is really optimized for the highest level of resilience, and it already has the inherent level of storage performance that ESA offers, and that simply becomes easier for the customers.
Well, yeah, on the topic of management, I noticed there's been a lot of new enhancements for vSAN 8 Update 2. I think the one that I thought looked really good was the capacity reporting. There's been a lot of changes there. Tell me about that.
Yeah, so capacity reporting is always kind of interesting in any kind of an environment.
Oh, yeah, tricky.
Very tricky. And it seems like such a non-trivial thing, or such a trivial thing, I'm sorry, for the end user. They're just going, well, you're consuming X amount of capacity. How hard is that to tell me? But the fact of the matter is that you have, when you're storing data, you're storing all different kinds of other data that help you find that data. That's known as metadata. And then there's various layers of that. So we need to factor all of that in. And then by the time you account for, blocks that are compressed and things of that nature, you need to also account for things like that. So in the recent editions of vSAN, and especially as we debuted the Express Storage architecture, there were some space accounting elements there that weren't quite reconciling with the actual space used. And that was something that some of our customers noticed, and rightly so. And so that sort of, it was one of the reasons why I had to write a blog post on it, just to help clear the air on that. So what we did was we made some additional changes within the UI to make sure that those numbers really reconciled. And so when you look at the overall cluster capacity usage, you will get a breakdown on some of this metadata overhead that will help you understand where is my space being used, how much, and what is it associated with. And that's ultimately what many of our customers simply want to know. They want to know, how much am I using and how much do I have left? And if those two things are really, really accurate, then the rest really doesn't matter. But they need verification that it is indeed accurate.
Yeah, for sure. And you want to know what you're spending your space on as well, right? So it helps to have that breakdown and to be accurate. Obviously, this has been this has been an issue as long as time in the world of infrastructure, especially storage. Especially when thin provisioning first came out, and trying to report that information accurately from let alone separate storage, has always been a challenge in the industry. But yeah, it seems like we've got this thing looking really good now, and the visuals are fantastic as well. So
no, it's something that I think back to just the earlier days of managing regular arrays. I once, for a customer, did a report of like usable versus raw. And like after we accounted for, weird array overheads, replication buffers, way too many snapshots, like just too many, RAID and other things. It was like 17% usable versus raw. And they're like, I'm like, well, I've seen worse. But it's something that people aren't always aware of. And sometimes people get angry. They're like, well, the OS reports this, but I'm only seeing this. And oftentimes accounting for this is fun.
Well, and we know even the manufacturers of the storage devices, they have different ways of reporting how much actual capacity is on that. Before and after formatting also is a big element there as well. So it's a complex challenge that we're always striving to make that better and simpler for our customers. But it is sort of interesting is that just when you think you have it figured out in terms of making this as simple as possible, then there may be another case where you go, oh, you know what, maybe there's room for improvement.
Absolutely. Well, another area that's definitely in the past has been sort of a challenge, with storage administrators has been disk claiming in general, the process for disk claiming, and I heard we have some good news in this regard.
Yeah, that's another dubious sort of thing that we've had within vSAN as far as the claiming process. And really that came from the nature of how we initially consumed the storage devices within the original storage architecture. Of course, at that time, we used the concept of a disk group where you had, the caching and then the storage devices for the capacity. Well, at the time of the original storage architecture, we initially rolled out with this ability to automatically claim the storage devices.
Yes.
The problem is that really didn't work very well, and that didn't work very well for a variety of reasons. It was hard to really distinguish what should be a caching device and what should be a capacity device. So we recognized that was a bit of a challenge. So we removed that out of the product and just had the manual claiming process. Well, manual was good, but just as the name implies, there's more effort there. With the introduction of the express storage architecture and its single tier, we were able to sort of bring back that automatic disk claiming method. And so that's good. But we also recognize there was one other sort of use case here, is that there is situations where customers want to be able to claim specific storage devices within those hosts, but not all of the storage devices. Right now, the automatic disk claiming method will claim all the storage devices that are on the HCL for vSAN. So if you want to have an additional storage device that's used for something else non-vSAN related, then that becomes a bit of a problem. And that was actually a challenge that we would run into with some of our vendors that had customized systems using vSAN, as well as VMware Cloud Foundation, and some of our hyperscalers as well. They wanted to be able to control that. So in vSAN 8 Update 2, we have a new prescriptive disk claim. And this sort of uses this model where you have this desired state. It's essentially a configuration of what you want it to actually look like as a result. And we use that manifest of sorts to help build out this desired state for any and all hosts within that vSAN cluster. So now you sort of get the best of both worlds, and the ability to sort of customize that, but have it fully automated. And in this release, it is only available via API and CLI at this time, but this actually works out great because some of those use cases and those examples that I shared, that's actually how they would be using it in the first place.
Yeah, that's how they're going to do it. They're not going to open up a GUI for that.
Right.
Yeah,
right.
That makes sense. Yeah. So what about stretch cluster? I know that's that's a specific use case. Not every vSAN cluster is a stretch cluster, but there are a lot of customers, especially depending on their distance between data centers or sites that take advantage of our stretch cluster. So are there any enhancements in regards to stretch cluster?
Yeah, we have two really good enhancements here that I think when I think about just even some of the meetings that John and I had at last year's VMware Explorer, these two things came up over and over again. The first one is being able to tag vSAN witness traffic in a stretch cluster right within the UI itself. In the past, you always had to jump out to the CLI, or if you had larger configurations and you wanted to sort of automate that, you might use Power CLI or something. But
why do you want to track the vSAN witness traffic? What's the purpose?
Well, we want to be able to split the different kind of traffic that vSAN is generating. We have two different kinds of traffic in that topology. Some of it would be essentially the data itself that is being replicated between the respective sites.
Yeah.
And then we would have witness traffic that is essentially transmitting metadata to help it understand awareness of where the data's at and quorum and things of that sort. But we needed, in that sort of a topology, we needed to be able to specify which VM kernel port it should use for that. And we had no way to do that within the user interface. Had to be via the CLI. Yeah. And so right now, it's just sitting as one of the respective services when you are configuring a VM kernel port. Just like vMotion or vSAN traffic, you'll see vSAN witness traffic there, and it just makes it really easy. And for those who are not necessarily in the CLI a lot, they're probably going to be happiest because it's usually you're not doing something like that just long enough for you to forget everything that you learned the last time around on how to configure it. And that's what we were really sort of striving to solve on this. Now, the other improvement that we made for stretch clusters was the support of the VM IO trip analyzer. So this is a really neat tool that helps you understand where the potential bottleneck may be in the performance of a VM when it's run against a VMDK. And so it looks throughout the stack, it figures out where this bottleneck may reside. It's been a great feature we've had for several versions now, but it's only been functional within a standard vSAN cluster. When it came to a stretch cluster, it didn't work. And now somebody might think, well, wait a minute. If it's a stretch cluster, I can pretty much guarantee that the bottleneck's going to be at the inner site link. Well, the reality is that that's not always the case. And it's actually more often than not, it's somewhere else, especially if the hardware isn't very good. So this offers full support for a stretch cluster environment as well as a two-node environment as well.
And this is something that you can try to measure the network and trace these hops and these devices. But if you start thinking about a large cluster becomes like a 30 factorial problem of I have one VM out of hundreds or thousands that's talking to one of hundreds of disks and one of, a dozen or dozens of hosts across, potentially multiple, networking paths, trying to figure out, okay, is this the networking? Is this one of the devices? Where did that IO go? Because this VM technically sits on 14 different disks. This is really cool. And being able to be like, why is this slow? I was actually looking over the top 10 VMware Explore sessions, and there is actually one of like, why is my VDI slow? But this is kind of the thing. Those are always one of the hardest questions to answer, and they're frankly even harder in a distributed system. And to be fair, like, you try to answer this in a 3-tier storage platform, you're having to look at an array and a special interface. Right, you're having to look at a switch. You're doing show int, on the switch. Maybe the networking guy at least was kind enough to give you read only. You're manually throwing pings back and forth, or you're like, if it's fiber channel, you're either using some weird fabric view software, or you're literally, I've seen people even go and this sounds insane, but this is actually a thing, deploy fiber taps. So they're literally like sniffing the photons, the frames in real time to try to figure out like where the bottleneck is. Like, this is the craziness. And like having all of this to where we own the IO path on all sides, we get to cheat because we have sensory telemetry on all ends of this IO path. So please try this out.
Yeah, for sure. And one question. So is this only for real time, or are you able to set a time where it actually captures the information over a period of time?
Yeah, this works with the new scheduler that we introduced on vSAN 8 Update 1. So you're able to schedule a time for these workloads that you may suspect that they are having some challenges. Yeah, you will certainly be able to work those schedules in a stretch cluster environment as well.
I like it. Very nice. So, Pete, let's pivot over to performance. I know there's several, and we won't touch on all of them on this podcast. Link below for the blog explaining all this, as well as by all means go to core.vmware.com to get more detailed information on all of these. But Pete, why don't we touch on a few of the performance enhancements in vSAN 8 Update 2?
Yeah, most certainly. So the first one that we are introducing really is an enhancement on a new capability that we introduced in vSAN 8 Update 1. In vSAN 8 Update 1, we introduced this brand new fully adaptive write path, meaning that we have more than one way that we can write the data. And that's really important because we need to understand that when workloads are generating the data, they issue writes in very different ways. And when they do that, and there's going to be different methods in which you can actually write that data in the most efficient way. And so our new adaptive write path allows for this sort of accommodation of these IOs, these incoming IOs that may be really small or really large. And so that was some of the capabilities that we introduced. It increased performance within the ESA, I think between like 25 and 30%, just with enabling that feature alone.
Wow.
Let alone some of the other performance improvements. So as an enhancement on that, what we did was we recognized that as we're absorbing those incoming writes so much faster now. We have to prepare that data in such a way that we can write that fully aligned full stripe write with its respective metadata really, really quickly. And we do that preparation and the coalescing of IOs within memory. And we use these IO banks that are set aside for this process. Well, in the past, for each and every object, we only used 2 IO banks. One would always be active for the incoming IOs, and then the other one would be preparing and sending that data to the underlying storage devices.
Sure.
Well, because we were ingesting the writes so fast, we needed more of those. But there's hesitation on doing something like that, because if you just do that statically, then you're going to be consuming a lot more memory and so forth. So we have this dynamic allocation of IO memory banks for each and every object that exists, so that we can tune it, fully dynamically tune it, so that more of these banks exist for a high write intensive workload, so that this data can be written to the storage devices in order and faster. And we want to make sure we pay attention to that in order part, because that's the unique thing about storage, is that you have to do things in an ordered way. Otherwise, it's not going to be the information that you expect when you actually try to fetch it. So that's one of the key areas that we made improvements on. The other part that we introduced some improvements on was really just looking at the stack again, the main vSAN stack, and introduce some additional threading that helps make sure that we increase the parallelism of these IO activities throughout the stack. We don't, and this actually is a truism for most software development, they don't build the software to have an unlimited amount of threading that occurs. It's really wasteful. That wouldn't serve it well if the underlying hardware was never able to use that in the first place. So we have to, as this faster hardware comes out and optimizations come to our stack, we have to make those adjustments as well. And so we introduce these things known as helper threads that help process those activities much more quickly. And so we did that, which really improves some of these like single VMDK workloads much, much faster. In fact, I was speaking with the performance engineering team just earlier today, and it was really quite extraordinary when they were doing some of the testing on the latest version of vSAN ESA versus what the capabilities were within the original storage architecture, both in RAID 6 and RAID 1. We are getting into the orders of magnitude faster now.
Wow. It's crazy. It's crazy to see how quick this stuff changes, right? I mean, we go from switching over to the express storage architecture, and after about 2 years from now, there's going to be nobody even considering anything. It's kind of like SATA versus flash. Like there was a time when it was like, well, price point, maybe it makes more sense, but now the conversation is strictly flash. And I think the more advanced the adaptive write path and all these other enhancements into the lower level architecture that make this just more intelligent and more highly performant, it's just a no-brainer that everyone's going to move to the express storage architecture.
I mean,
it is. And
it's something that recently I was doing some benchmarking in the lab, and I wasn't even trying to actually do serious benchmarking. I was just running a single synthetic generator to a single VMDK, and I was getting 12 gigabits a second or something, which previously, if you'd worked with VMware storage and you were trying to push high throughput, you'd be like, okay, I need to get out like 8 VHBAs and like 14 VMDKs and do some striping and something uncomfortable. And have you considered scaling out your application and seeing that that with literally zero tuning, zero effort, I'm able to push non-trivial amounts of throughput to a disk subsystem. It's pretty cool.
Yeah.
Yeah,
Well,
and it really, really ties in so nicely too with the work that we've done for vSAN Max, because we, in a lot of ways, many might look at the kind of that original storage architecture within vSAN. You're thinking, okay, well, that's an interesting hyperconverged sort of arrangement. Well, with the ESA and a lot of ongoing evolutionary sort of improvements with our control path, what it turned out that we did was we built a really great fully distributed storage system. And that's where we're applying it to in the form of vSAN Max.
Yeah. That makes sense. And now with more performance, there's, because performance being a big bottleneck in the past, you're not going to put a lot of VMs on the same host. But with all of these performance enhancements, I understand that the level of capacity for putting or the scale of VMs per host has increased. Is that correct?
Yeah, for those that really want to ignore some of the design recommendations, this next feature is for them. We now support 500 VMs now per host when using vSAN ESA. And so this is really quite an extraordinary improvement over the 200 VM max that existed within the original storage architecture. And this comes really from the result of two things. We use less resources for each and every I/O that is processed. So when a guest VM issues a write, I think on average, the ESA is running about 1/3 of the CPU cycle. So much, much lower than the original storage architecture. Then along with some other enhancements and performance improvements and internal changes, the result was that we were able to revisit how many VMs is it that we want to support in an environment. And so we were able to make this change here, which was about 150% higher or something like that. So quite extraordinary. Now the question becomes, do you really want to have 500 VMs on a host? And that's sort of, I think it's something that you need to address on the design phase of your effort. But that is a question that you would have, and this is really important. That's the same question that you would have in a 3-tier architecture. So the data itself is actually not relevant in that respect. It's all about the number of VM instances that you're willing to lose.
How heavy the CPU scheduler is getting hit, how large an HA blast radius. I typically find the people who are trying to push more than 200 fell into a couple of camps. People who were doing like weird build test stuff where these things were running super lean, they built it a certain way. It ran 10 megahertz for 10 seconds, and then it just sits there and does nothing. VDI with like quad socket people who I don't understand why you don't just go to more 2-socket hosts, but UDU. And then for whatever reason, like weird government institution people to where they won't even tell me where they work. And I don't understand their use case, but these people do exist. But I just, Pete and I kindly ask you, think before you leap. Think about if a host fails and I have VDI users, how many of them I want calling my help desk before they, HA kicks in and reconnects them.
And I'm curious. So for those listening, shoot us a DM at VertSpeaking on Twitter. I'm curious what the typical host looks like. How many VMs? What do your workloads look like? Send us a message. I'd love to hear from our audience. Awesome. So Pete, it is, like I said, it's VMware Explore Week. Today is Tuesday, and you actually have a session today. Tell us about the name of that session and how people can listen to that.
Yeah, indeed. So later in the afternoon of Tuesday, we will have a deep dive in vSAN Express storage architecture. Duncan Epping and I will be presenting in some room that I'm not sure what it is yet. I think that's the best way to describe it. But if you haven't registered for it, you may be too late. But nonetheless, it's always worth showing up and seeing if you can get in. So
yeah, get online, I'm sure. And if not, you'll have to watch it on demand like everybody else. But
indeed, and there's always the possibility that, of course, John and I, our session occurred on Monday, but there's always a possibility of a repeat for that. So stay tuned and sign up for the session, and there may be a repeat.
Yeah, so we will leave links on the show notes to all the related sessions and all the blog posts and good videos. Last thing before we close, Pete, did you notice John's picture on his wall?
Well, now I do.
I really love this picture, and I need an exact replica for my office. No, not the cloud. There you go. Zoom in. There we go. Look at that. Can we get an autofocus? Let's see.
Is it going to focus? It's sort of
coming. There it is. Sir Nicholson. I love it.
My wife got that for me for my birthday.
That's beautiful. John, very good. For those at VMware Explorer, come over to the booth. We are podcasting all week over by the VMware communities. For the rest of you, take advantage of all the resources on the virtually speaking on vspeakingpodcast.com as well as core.vmware.com, and enjoy the rest of your week. Thanks, Pete.
Thank you.